This is a video for AQA Discrete Mathematics, Graphs and Networks, section 4.5, where we're looking at network flows with upper and lower capacities. Well, in previous videos we've considered networks where we just have an upper capacity and the minimum flow has been 0. However, sometimes we have to have networks, or we consider networks, where there is a minimum number which is quoted for the flow through sections of the network. So for example, here we can see that from S to D, two numbers are quoted there. 5 is the minimum flow that is required from S to D, and 12 is the maximum possible flow. Previously, when we wanted to find an initial flow, one way was simply to assume that the flow was 0 throughout the whole network. However, we can't do that now because we've got to have minimums. So one way is to say, well, let's assume that the minimum flow goes through here. So for example, we put 5 from S to D, 3 from S to A. We go through doing that for all of these minimums. And that would mean that we've satisfied those minimum flows, but we've got to check, does that actually work? So for example, if we look at D here, that would give us a flow into D of 5 and 1 and 2, giving us 8. Yep, that's fine. What about here though, where we've got 3 flowing into A, 1 goes up to D, but only 1 coming from B. So that's not going to work. We're going to have to increase the flow from A to B. And again, if we look at the flow here, we've got 4 coming out of B and 2 coming out this side. So we need at least 6 coming into here. So that 1 is not going to be sufficient. We need 6 coming into there, which means that we must have 7 coming from S to A. Now let's continue through the network. We're okay at B, we've got conserved flow there. B has now got 6 coming in and 4 coming out. So let's continue round the network then from B, come up here 2, and yes, we've got a total of 8 coming in and 8 out. But now we've only got 5 coming from S to T, so we need to change that also to 8. Now we've got a flow pattern which actually works, which satisfies the minimums. 5, 7 is bigger than 3, 6 is bigger than 1, etc. And also shows the conservancy of the flow at each of the nodes. Another difference with networks which have got minimum and maximum capacities is that the value of a cut is actually different. The cut in this position here is still going to be the capacities 13 plus 10, which is equal to 23. But let's consider a different cut in here. This time we've got 8 flowing from the source set into the sink set and 14, but we've got a line going from B to D. Previously we would just have ignored that because it would have had 0, but now we have to subtract the minimum capacity of 2. So the cut that I've indicated here, which is the set S, A, D, cut with T, C, B, has got capacity of 8 plus 14, so those are the maximum capacities going from source to sink set, and then minus 2, which is the capacity, the minimum capacity going from the sink set back into the source set. So we've got to subtract 2, giving then a total of 20. Let's consider one other example of that. So here's another cut, this time dividing the set with the source set SD and everything else in the sink set. So remember, we're looking at the maximum capacities going from source into sink. So 14 is going from D to C, and 11 is coming from S to A. So we've got 14 plus 11, but then we've got 2 arcs which are going from the sink set T into the source set, and the minimum capacities of those are 1 and 2. So from A to D and from B to D, those minimums are 1 and 2, so we must subtract those, giving a total cut capacity there of 25 minus 3, which is 22. Now the max flow min cut theorem still works in these situations. So as long as we make this change to the way that we calculate the cut, if we can find a cut which is equal to a flow, then we know that by the max flow min cut theorem that must be a maximum flow. Well, here's an example for you to try. What I suggest you do is just pause the video for a couple of minutes. So if you pause it now and then try it yourself. Well, for this particular cut then, we've got 17 flowing out from the source into the sink, and from Q to V 16, and from R to W 20. So outwards we've got 17 plus 16 plus 20, and then coming from U to Q, this one here, which is going from sink into source, the minimum is 9, so we must subtract 9 from there, and that gives a total value of 44. That's the end of this video. In the next one we'll look at how we find flow augmenting paths with upper and lower capacities.